as head of infrastructure. And I'm going to talk about Amazon CloudFormation or infrastructure as a code today. So with like with a demo of how it actually works and description what it is and why you should use with like some simple examples and some demos. So short introduction about myself. I already said I work at Inbank. It's a new Estonian bank, which is already 2 or 3 years old. I don't really remember when we got the license, but it was like recently. My title is head of infrastructure, but actually the infrastructure team is like non-existent. I am the only one in infrastructure. I am doing the infrastructure myself. And why the title of head of infrastructure is mainly because of some legal papers and some other stuff, because apparently you cannot use on papers a title called software developer. I don't know why. You can also call it a DevOps, SRE, site reliability engineer, and a SysOps. You know, whatever people call it, because when you look at, let's say, at LinkedIn, whatever people like job offers you get, it's like the title is usually called whatever. And I suspect in 2018 it will be called something else. So it's pretty much placeholder plus infrastructure. And I also have a very epic domain. It's Andres.whatthefuck. But beware, the website is actually very outdated. I made it like 2 years ago and I haven't updated it. I haven't had time. So what is Amazon CloudFormation? How many of you know, or how many of you have you used it? All right, cool. But how many of you have like used, wrote infrastructure as a code somewhere else, like Terraform, Microsoft, Azure, or the Google Cloud Computing? All right, so I see people prefer Amazon. So what is Amazon CloudFormation? It's basically templating kind of platform where you can write down your Amazon resources in either a JSON or YAML file. So you write them as a code. You just write down what resources you want to be launched in Amazon, instead of like doing it manually by hand through UI or command line. As I already said, you can like easily define all the resources, all the relations between resources in your YAML and JSON file. It's actually very like easy and straightforward. It's also, Amazon CloudFormation has very nice functions inside YAML and JSON templates, which means the function you can use to, I don't know, reference all kind of resources from, let's say you launch resource A and then you launch a resource B, and resource B is like linked to resource A or is depending on it, so you can use all kind of functions to link them together. And Amazon CloudFormation knows how to do that, so it's easy.
So basically have like an API to describe groups or kind of thing.
Yeah, it's not an API, it's pretty much an API. It's if you look at the Amazon CloudFormation documentation, the documentation is pretty much based on their API. The Amazon API is the same as every SDK. If you have ever used, I don't know, Ruby, Go, Java SDK, the functions are pretty much the same. The function names are same, or if you use Amazon CLI tool, the method names are same and the parameters are same. That's actually a very good thing about Amazon. So they try to make it as similar as possible. It has not so nice tool to draw your resource based on that template. I think the tool is called some CloudFormation Designer or whatever. I have used it only once to show like how many resources we have or how they are linked together. But why I say the tool is not so nice, because I figured out that it cannot, when you use nested stacks, for example, you launch one Amazon CloudFormation stack and another one, and they're linked, and one of them launches another one, then the tool cannot link them kind of together, or doesn't have the opportunity to like list you multiple stacks, so it cannot show you the whole Amazon like structure you have. But it would be really nice if they do it one day, and then you can make some nice picture for your business and show them like, this is how much resources we have. It's not like one server. It's actually very easy to write and understand. So what that means is when your infrastructure guy or DevOps guy is like sick or on vacation, I can actually give it to any senior dev, and he can open the file and he can easily understand from the file of structure how is anything related. Let's say how is your networking done, or I don't know how your application is built, or what's running inside, how is everything named and so on, or like a security group. You want to know like that who can access your load balancer, from what IPs access is like given. Just open the file and everything's listed there, or you can go to Amazon CloudFormation and also like see everything there. So I've actually wrote out another tool, similar tool called Terraform. Has anybody heard about it or written anything with it? Terraform is basically similar to Amazon CloudFormation, but it's not provider linked or related, because Amazon CloudFormation, as the title says, it's like Amazon related. You cannot use it anywhere else. Maybe OpenStack, but I'm not sure. For example, you cannot use it in Google or Microsoft. And Terraform is open source command line tool written in Golang, I believe. And it pretty much lets you write your code also as a JSON or YAML. I think yeah, it offers YAML as well. And but there you actually have a choice of using different cloud providers. Like there's 10 or like more different cloud providers. I have heard many companies use it, and when I was deciding what to use in InBank, Amazon CloudFormation and Terraform, I analyzed both tools, and actually even had a small GitHub repo where I actually made exactly same stacks, like very simple stack in both of them, to actually figure out what are the differences or what I like about one or another. And I did it, I think, a year ago, or maybe more. And here I'm actually going to bring out only the problems, because the good points about Amazon CloudFormation I brought in the previous slide. And in this slide, you can basically, based on the problems, you can figure out what Terraform has, let's say, better than Amazon. But as I said, I haven't got very deep into Terraform, so I cannot bring you all the good points about it, or I don't know exactly all the problems. It's just my personal opinion based on this one single example I did. So CloudFormation is quite slow sometimes. That's my opinion based on when I compared it with Terraform. I don't know why, but Terraform was, when creating some resources or updating some resources, it was much faster. But CloudFormation can be like slow sometimes. So pretty much when you launch a CloudFormation template, most of the times, or you update existing template, you just click a button and then you go take a cup of coffee or 2 or 3, or like you wait all day.
Question, how slow is slow?
Slow, it depends on the resources. For example, when you update an Amazon ECS, which is a Docker service, it updates it in a blue-green deployment if you have more than one instance. So it, like, based on how long your application boots, it takes some time for it like to fully validate it, because Amazon will create a new task definition, it will launch a task definition, it will wait until it's like fully functional, and then it will start deleting the old stuff. So that takes time. Or the slowest thing I saw was you either create a database, that's extremely slow, or a CloudFront, because CloudFront by itself is like takes very, very long time to create. But if you launch it through CloudFormation, it's like probably even longer, so you just sit there and wait. What I also don't like about CloudFormation, the UI looks pretty nice. You can see all the details, like you can see all the parameters used, outputs, events. but UI literally requires too many clicks when you try to update or existing or create something. It's like literally click, 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 click. And if somebody thought that, it's like, if your UI requires too many clicks, why wouldn't you use Amazon CLI? Well, because writing this kind of update stack or create stack commands in AWS CLI is extremely complicated and long, because then you would either have to, let's say if you use parameters in your stack, and you probably use, and you can have up to like 60 different parameters that you have to define, like, because you want your stack to be like as much as reusable as possible. So you define all kind of, I don't know, security group, IPs, like environments, like your application environment variables and so on. And if you try to do that through Amazon CLI, you have to either like write out every parameter every time, even if you update and you select like use previous value. I don't want to update existing value, just use the previous value. You still have to type it out. I have to write like use previous value equals true. Or you can create a JSON file where all parameters are listed and then you pass in a JSON file. That's like, that also doesn't remove the complication that every time you add a new parameter, you would have to edit the JSON file. So it's like, it's pretty much faster than you go to AI, click some buttons, and you just like put in the parameters in nice UI and just wait. So yeah. I have a repo where it's like this actual demo is located. It's in my GitHub. You can later find it out, but it's like old. I made it 1 year ago and extremely small. So yeah. What I didn't like in Terraform when I tried it compared to Amazon is that Amazon, let's say when you create resources, list of resources linked to Amazon CloudFormation, they are all stored in Amazon. It's like stored internally, so when you delete a stack, it knows what resources to delete or update. You don't have to like specify or like delete them manually. They will be all removed. But in Terraform, I found out that when I use Terraform, it actually list of resources created, and when it applied some unique IDs, it stored all of them in local, like some dot or JSON file. What I didn't like about it is that, let's say, I don't know, I lose the file or I forget to update the file, or somebody updates the file and doesn't show me. So you would have a GitHub to manage them, or you need some custom database integration to manage these files. And I, like, compared to Amazon, like built-in internal easy tool, I didn't like that idea. Because in Amazon, it's like everything's already there, so why would I implement something else? When I found out that initially CloudFormation, when I started writing the stacks, my idea was that I create, let's say for one single application, we have many of them, I create a stack with as much parameters as used, so the stack can be reused. Let's say we have an application called, I don't know, application A, and you launch it in one web, let's say, with, and it's in the environment staging. And now your business or QA says like, I want exactly same stack with a different branch, same environment, same everything. So you just take exactly the same file, you pass in the different parameters, you put different names, and you launch it, and it's there. You don't have to do any magic. It's up and running, so it's easy. And with Terraform, maybe there is some harder way to do it, but the easy way in documentation, I didn't find how I can use exactly same like a file or a stack to launch a totally different one, totally different like a stack, because it like the file is like initially used to launch one single thing, and then it's stored in a file. So that's the things I didn't like. Alright, and this is how like usually what happens when I try to update my CloudFormation stacks or create one. So you just wait, and there is magic happening in the background. So yeah. Well, now let's get to demo. As a demo, I wanted to first show you, or like not show you, how tell you, go with you through the process of creating simple web resources in Amazon by hand, and then I will show you exactly the same thing how it would have been done in CloudFormation. But I will be not doing the demo of creating it simple by hand by showing it in UI, because I don't have 3 hours. and so many nerves. So what steps like would you do to create, let's say, in a fresh Amazon account, some environment for your web app? It's based on my personal experience. You would, of course, create virtual private cloud with some private public subnets, because you know how you want to hide your app. You want to do everything like pretty neat. And then you would, I don't know, create IAM users for your team. You would start defining policies inside there, who has access where, how. Then you would F up some IAM rights, because like you made some rights, you wrote them down, now you give access to developers. Developers come back to you saying, I don't have access to it. What the fuck, man? You're like, you go back, you start modifying the permissions again. It's like, you probably still fuck it up somewhere, probably leave some bug. Everybody has, like one of the developers have access somewhere that he shouldn't be. As I said, you F it up even more and make everybody admin, because it's like, at first you try to make it beautiful, but in like a couple of months it turned out it's to be like too hard to manage. You're like, I'm gonna make everybody admin. Everybody is responsible for his things. Then you're gonna create EC2 server, install some stuff manually. Like initially, if you would be like, if you're not in a rush, you would like write down everything that you installed. Like, oh, just in case, I'm gonna make either a script or Ansible or like something that I can reinstall it later. Yeah, you do it in the beginning. Later, you install some stuff manually and you don't document it anywhere. Happens every time. Or like, let's say, if you're running Docker, you would create EC service, task definitions, roles, rights. Like in reality, basically, you do it once, but when you start thinking about it, how much Amazon resources you have to create in order to launch something, let's say, simple or not so simple, it's actually pretty a lot of resources. There were 100 resources. You have to create policies, roles for everything, and you shouldn't like reuse the roles and policies on all of your servers, because that makes bugs and holes and brings out all kind of problems. You make your one single application should have the policy it needs. If it needs to access one single Amazon bucket, you should give it a policy to access only that bucket with that existing rights. You shouldn't give it access to, I don't know, to all your Amazon, because it was easier to do that. And when you do that manually, you will go nuts. It will be crazy. You cannot remember all the relations or what everybody needs. You cannot remember all the names you gave to these resources. It will be like literally, it will be like this, that you did it once, and then every time you go to Amazon, you will like couple of hours or minutes, you will start searching resources. How is it linked? I don't remember anymore. What next? You created a web app. You wrote everything down, and typically, I don't know, that happened a lot. That you figured out that you can't access your web app, and you're gonna make it. You're gonna quick fix it, or you're gonna test it out. But I'm gonna make the security group public in order to test it out fast if it works or not. Of course, it was like temporarily. You made it, but you forgot about it. And half a year later, you will get your ass kicked by auditors or penetrators who found out that, oh, wait a minute, you had one security group open. I'm pretty sure some of you have security groups open to public, or the ports that are open to where they shouldn't be open.
Well, we might.
Yeah, that's quite common. So what problems came out of this scenario is like, and why you should write your infrastructure as a code. It's also based on example, on my personal experience, because we were also, as a small startup, we started, everybody thought it's gonna be easier to write do everything manually, and when you start growing a little bit, like we'll do exactly the same thing, we just document it. But yeah, that doesn't work out at all. So, cloud, if you run your instances with cloud can guarantee you one thing: your instance will die. It doesn't matter, it doesn't matter when, how. It doesn't matter how much alarms or monitoring, it is gonna die. It's like Amazon even sends you an email saying that, hello, your instance will be terminated on that date because we found some, I don't know, there was some issues. Like, or your instance is already inaccessible, have fun. So that will happen. It will die in cloud. It doesn't matter now, in 1 year or two, it will die, don't worry. You will not remember things you did manually because you might write it down, but in the end, it's like you might remember it today. In 1 year later, you will not remember it. It's impossible. This scenario can't scale because, let's say, imagine you did it manual. Now business comes up to you and says, we need actually same environment but in different Amazon region. What are you gonna do? You're gonna start like doing exactly the same thing again like a monkey. You will be scared to modify anything because if you don't remember what you did or how it's related, you're even more scared to modify especially the production environment. And like how scary it is now to modify security group because you most likely if you modify it and you restrict like access that it shouldn't be restricted, your app is inaccessible to your customers. Now you're like very sad. And there is no actual written down current state of your infra. You can write it down in like, I don't know, Google Docs, Jira, whatever, but it actually doesn't, it never represents the current state. It might do it now, but tomorrow some developer as a quick fix might log into a server and install some software that is not written down anywhere. And then your server dies and you launch a new one and it turns out it doesn't have this package installed. Back to the point that, as I said, some things will be missing from documentation. Even if you try as hard as possible, some things will not be there. And then there are problems with like security groups, connections, NAT machines, whatever. You will end, like everything you did manually, you will end up going to the Linux instance yourself and you will start debugging. What's the problem? The connection doesn't work. Where does the connection stop or where does it drop or like, what's wrong with my routes? So yeah, you will get pissed off, tired and very angry. And you can't reproduce exactly the same environment. That's the most important thing because you will not want to modify your production. You're supposed to test the things in your staging to test environment, but you cannot launch exactly the same Amazon environment because you did all the things manually and it will not be the same. Never. Okay, you're all probably bored, so let's do some actual demo in CloudFormation. So,
can you make font a bit larger here? It might have some
presentation mode
or whatever.
Yeah.
Command Shift A.
I found it like that. No worries.
Don't judge him hard. He actually is a Vim guy, new to ID stuff.
Yeah. Fuck, where are my files now? Shit. So anybody knows how to get the backlist of files I have open?
Apple 1, maybe not.
Command A.
Command A?
Command E, I mean.
No? Alright, that's better. So I actually propose a thing. I made 3 different templates for a simple app. I made IAM, which will create users and like for your team. I created a VPC template, which will create the basic networking stuff, extremely simple one, and then ECS, which will launch an extremely simple Apache template. But as I showed you on previous screen, whenever you launch an Amazon like template, it takes some time. So I propose that I will launch these scripts right now, let them run in the background, and we can analyze the file, and I can later show you output in Amazon CloudFormation how it was done. And I made extremely simple, I don't know, bash script to launch them on with Amazon prepared command. This is how I do it. It's quite easy, but
can you maybe guide through the arguments? What do they actually say on the commands?
Exactly what they say. Create stack.
But there's like a
stack name. You put in a template body, and as I said, the biggest problem is parameters. Right now, these stacks have only one parameter, which is a default password for the IAM users, which is the initial password. When you create IAM user, it sets his initial password. So when developer logs in the first time, he can log in with that password, and then he's forced to change it. And I wrote them down here. So doesn't look very beautiful. Now imagine if you had 60 parameters, you would have to write them all down, or yeah. So you pass in template body, your parameters, and one pretty hard to understand thing is the capabilities. Is whenever you modify IAM or any IAM related resources, it's like when you go through UI, in the last page when you're creating and updating a stack, there is a check mark buttons like I allow some IAM like capabilities. If you don't click the check mark, it starts creating your stack. You're waiting, and then in a couple of minutes it says, sorry, you didn't click the check mark, fuck off. Redo it again, delete and start again. So in that case, command line is a little bit better. That when you try to create without capabilities, it's gonna tell you an error right away that, hey dude, you didn't pass in the capabilities, which is like basically you're allowing to telling that, hey, I'm gonna modify the IAM resources or update them or like whatever. And that's pretty much it. You pass in the stack names and so on. So first I create IAM, then VPC stack, and they are not related, meaning that they don't share the resources. You don't have to create one of them earlier. So I launched the command right away, and I'm not waiting until they are finished. But the ECS stack requires VPC because it requires some main networking setup. So yes.
So I see that you have the AWS commands. So I never used it. So I'm asking, like, where did you get this AWS executables or something like that?
This is a shell script.
You can the Amazon command line. You can either install it with a pip or like with a brew, or just download them. It's like the official Amazon tool. It's quite easy to install.
Okay.
But I will later show it how you can do it in UI as well, in Amazon UI. Just I sometimes prefer, like for example, for a demo, I preferred the command line because it was faster. And I also added one third command, which is wait stack create complete, which is basically Amazon command, which will just wait until your VPC stack is fully created. It will just ping it every 15 seconds by asking, hey, are you finished or not? And then I create the ECS stack, which actually uses some parameters from VPC in order to like know where to launch the stack. So I'm going to launch it, and then I'm going to show you how it's actually done and what we're actually using. So let's start with IAM. This is Amazon templating format. You can just check out their documentation. It's like very easy format. First, you pretty much the first two parameters are, you don't need to remember them. You just copy them every time. This is some Amazon internal stuff. This is like boring. The description, of course, you can put the description for yourself. It's not pretty much used anywhere except just showing what's inside the stack. But yeah, the description usually is useless because you know the stack name and resources inside, just for fun. And then you define the parameters that you want, mandatory or default values that your user must pass into the stack when he's creating them. And these parameters you can later reference in your stack. So you don't have, let's say, you want to pass in this default password. You don't want to hard code it in your, I don't know, CF file and then upload to GitHub, because who does that? I know some companies do. I read it in the news. But yeah, usually you reference it here. So you can actually also define some parameters like no echo true, which means that it will not shown in UI or anywhere. So you cannot find out what's the value of that given parameter anywhere. It will be hidden. It's a password now. So then you actually create your resources, and I usually add comments as well to make it easily understandable. It's like the first one are extremely easy. You just make two IAM groups. One is called admins and one is called developers, and it doesn't have any policies or anything related. First you create the resources. It's like very easy. If you open the documentation, it's like, I don't know, matter of a day to learn how to do it. And then you define a policy, for example, which is like admin policy. As you can see it, all the rights will be defined here. You reference that the policy is related to a group admin, so it's automatically added to a group admin. It's like created like that. And as you can see by the policy document, to admin is allowed to do everything. There is like right is given to all resources everywhere. This is usually given to everybody, yeah? And then you create an actual developer policy, or what should look similar, like developer policy should probably look like, is where you actually write down the resources they need to see and need to do. For example, this one allows the developer only to describe EC2, ECS resources, RDS tag, and CloudWatch. What that means, developer can't actually modify now anything. Developer can only go to given consoles, this CloudFormation, ECS, EC2, and he can actually just see some of the details that he needs, like IPs of that EC2 instance. He starts to debugging or something. He actually doesn't need to like modify anything. Like, of course, if he needs to modify, then you just add the rights here, and you don't have to remember what rights anybody has. Or when auditor comes and asks, like, show me what rights anybody has, you have them in GitHub. You just give them a link to GitHub and have fun. And then you create your users. The first user is, for example, admin, and you reference, as I said, you can use CloudFormation functions to reference all kind of previous objects. And the cool thing is that when you reference an object inside another Amazon resource you created, it doesn't matter in what order they are made, because if you reference admins group here, admins group will be created still first. Even if I move this resource on top, so you don't have to say like which one depends on which one. It's like Amazon understands it because of your references. And if you don't have any references and you still have some resource that depends on another resource, for example, the load balancer, target groups, or whatever, then Amazon also allows that. You can write that depends on, and you can write that what and it depends, like launch me this one first and then another one. So there are pretty cool functions and stuff. And that's it. You create two users, groups, and policies. Simple as that. And you have everything defined in GitHub. And let's go to simple networking setup. There are a little bit more parameters, as you can see. Is CIDR block for the VPC, and the same blocks for the subnet A and subnet B. This is extremely simple. It is like two subnets. Initially, in like production, you would like create like more subnets, private subnets, something more complicated. And that's it. You pass in the default values, and somebody can create a custom values. And you can add all kind of patterns, how it should look like, and Amazon will actually validate it. So if you put an invalid pattern on a string, Amazon is going to tell you that I'm not launching a stack. Please use the correct format, so you cannot make some stupid mistakes. Then you create a virtual private cloud. It's like reference to your stuff, and if somebody of you ever did virtual private cloud and then not EC2 machine inside, like a simple NAT routing service, then you know that, for example, when you start debugging it, you have to enable all kind of DNS hostnames or DNS support on Amazon private cloud in order to allow the like routing. So later you don't have to Google for these kind of things. They're all written down. It's like easy and understandable. You create your subnets, you create your root tables, and then you actually create root table associations, because you need to, now you created a root table and a subnet, and they are not related by default in Amazon. Now you link them together, like you associate them. So you can already see that VPC, for example, compared to IAM, creates a lot of more resources. So imagine creating all that by hand. And if you have much more complicated environment, it's like just complicated. You create your gateway, you create your routes. If you have your NAT machine, you can reference it here, create automatic routes. And this one uses a new block called outputs, which is in Amazon CloudFormation, you can define outputs of your stack. So you can output some custom attributes or custom names, like, and then you can actually, when the stack is ready, you can see the list of outputs, and you can export them as well. Export means that they are exported to some global Amazon CloudFormation globally. So you can later reference that export in another stack. So you don't have to link these two stacks. For example, I don't want to link my main networking stack with some app, because networking I created once and then I create different apps, and I want them to create them at once. I want to create them like a separate order. That's why I like export them here, and I can later use it anywhere in Amazon. So let's take a look at ECS, which is a little bit more complicated, because here you have to create all kind of things for, let's say you want to launch a simple app in Amazon ECS. For that you have to create many resources. For example, you need the ECS service role. In here you also have to define all kind of rights. You shouldn't give it like all the rights. You need like give it some special rights and so on. So you create a couple of roles. You need a profile to everything function properly. Now let's say you define your security group. As you can see right now there is only port 80 open, and it's open worldwide. So if you want to, I don't know, use the same stack in production and staging, and you want to basically create a different access based on production and staging. Let's say in production you want your load balancer to be publicly accessible for customers, but in staging you don't want anybody to access your staging except your office. So you can use the Amazon if functions to actually define here that if it's like the provided parameter is staging, then create me like a publicly accessible like in security group ingresses. Otherwise create me some internal restricted to this like given IP. So, and then you actually don't have to write like duplicate stuff or create them. You have one file and you launch it, and then you just choose, oh, launch me a production, launch me a staging environment. Easy. You create scaling group just to launch your servers automatically. Create your launch configuration. You create your cluster with everything defined, your app defined, how it works. You create your load balancers, everything linked, related. You create your target group, and of course in outputs I would like to see the ready solutions load balancer. So you create everything in one. So let's take a look if the script has finished and created something. Oh shit. Right here. So yeah, as you can see, I created 3 different stacks and they just finished. And this is the Amazon UI for CloudFormation. It's very easy. Your stack has some overview with some failed names. Okay, my computer decided to connect to another Wi-Fi. What the hell? Alright, it should be fine now. Here are the outputs you defined. We cannot see the full screen, but okay. As you can see, this are the like outputs and the values you define. So this is like show me some easy parameters when you have too much parameters and you want to access them fast.
Question.
Yep.
So if you create 2 stacks and you have 2 outputs of the same name, will the second one fail?
It depends if your output is on global export or not. So you define. If it's just an output, then it's related to a stack, then it's not global. But if you create an export that you want to use globally, then the name should be unique. I will later show you where you can see all the exports.
Yeah,
So
if they are not, will it fail or just overwrite?
no, it will not overwrite. If there, I mean, if you define in one stack or different stacks, in 2 different stacks, they are not related. They are not related, or they can be same name. Nothing will happen. You will just see one stack, one output.
If I export globally from both,
They will fail. Let's say if you already created an export, now you create another stack with same export, your stack will not get created. You will see an error message saying that the parameter is already used. So this will not happen. They are unique. And then you can see also events, what was happening, what it was creating, and if something failed, you will also see here that saying that you put some parameter wrong, I couldn't create, I don't know, root table or something like that. So everything's listed here. You can also see your template. You can see the parameters passed in and used. As you can see in virtual private cloud, I didn't pass any parameters, but because like say I used the default values. As well as any Amazon resources, you can tag them. You can create some stack policies. This is more complicated, and so on. And in ECS, for example, I created one single output, which is a load balancer. So let's see if it worked as well. Yep, it worked. As you can see, it created a simple app. So it created probably like 50 different resources, and I didn't have to do it by hand. Because if I had to do it by hand, it would have taken me a day or 2 or 3. It would be like crazy.
Would you repeat what kind of app?
Simple Apache running, not an app, just an Apache
So
running showing it.
For to get the batch running on the balancer, you have to do all
Inside the
this.
Docker container on EC2 container service.
In order to get your app running, you will just basically in a Docker, you will tell what image to run, where to get it from, your registry, your ready image. Or let's say if you are running not a Docker, but just EC2, then you define here, like in CloudFormation, you define how, based on what image, how you want to run and what scripts inside you internally want to run. This is more, how you launch your app will be more like app-specific installation. The CloudFormation handles for you the global infrastructure, how you create your like base or infrastructure where to run your app. How you launch your app, you should define it like in other places, like for example, for a Docker, you use it here.
Okay, so here you define your networks, your worlds, the user.
Everything, all Amazon resources that you launch, because for a Docker, for example, you have to define task definitions in order to launch your app. You don't have to do anything else. So for example, if you launch a Docker app, you define everything in a YAML file. That's it. You don't have to do anything extra.
Okay.
Have you defined the task definition for this app in the...
Yes, I can show you. The task definition is here. As you can see, it runs 2 containers. One is app, which is based on HTTPD image, so pretty much Apache. Well, basically all the parameters that you define in UI. You know, the command is pretty much copied from Amazon, which just creates some simple HTML file. And then another container, BuseyBox, but BuseyBox is rather just used as a container. So yeah, it's like in reality in production we also use task definition, but we have more complex and bigger apps. So the task definitions are bigger because we have environment variables and stuff, but still in order to launch an app we have defined everything in a file. So when I launch a stack, I just create a file, I just create a stack and boom, in like 15 minutes everything's up and running.
Task definitions are versioned differently. So that, are you updating if you need to roll out a new version of the application? You update the task definition from this CloudFormation template, and then you basically update
It depends, like if you modify task definitions, then of course you have to do it here. But if you just didn't update the task definition and you're rolling out a new version of your application, what we actually do, we use a Jenkins for that. This one creates initial one with a task definition like number version 1, and then we update like a we want to like modify a branch or launch a totally different revision. We use a Jenkins for that, which uses more like more complicated like Ansible wrappers or whatever that I made to update the stuff. Ideally, in an ideal world, I would love to use that for like updating the task definition and rolling out new revision. But let's say we have some more complicated things that we need to run there, like migration, some other things that you cannot run through that, because this one is used to make initial setup. And for deployment, we just use something else. But whenever we need to add a new environment variable, for example, or update, I don't know, some memory, then of course we do it here, and then you just push in the update and it creates a new task definition with just the revision you just say to launch.
If you just ship the new code, you don't have to use CloudFormation as your delivery tool. You can rely on like existing tools which we're using.
Okay, so let's say you created the stack and this task definition initially has revision 1. Then you, on the side, from Jenkins deployed hundreds. Basically, you did 100 deployments. Then you want to update your stack, you update some memory or I don't know what not. Then the update fails. And CloudFormation rolls back your infrastructure to task definition version 1.
That's why we have task definition 1 is always, we have one image called like latest or master latest, which always has like latest stable revision. So we have one single revision that is always stable. So when we roll out new, let's say, images, you can put a different, like tag them differently. We tag one image with like always the commit hash, for example, and one, the most stable one that is deployed to a master, that will be deployed to a master, is always called the latest stable. So it pretty much, when it rolls back, it cannot fail. So.
But then you need to somehow on the site also keep track what the latest was at some particular moment of time.
Well, we try to keep it that way that it's like master should be always up and running. You never have to roll back a master. Whenever there is something in master branch, for example, wrong, you usually do a hotfix. We never have had a thing where we had to roll it back. But in that case, you can write your own wrappers. Let's say when you deploy a new revision, you can run your complicated things, and then initial deployment, you can actually run also Amazon CLI to actually update your stack with your revision, and then your stack always knows what was like previous revision. So then in that scenario, then it would roll back to a previous revision that was used, because it would be defined as a parameter, for example.
This is what we do. But how do you deploy from Jenkins? Do you have a plugin or just use some script?
No, I wrote some Ansible script that pretty much takes a current task definition of Amazon ECS, it's like service that is running, takes the latest task definitions that it's running. It modifies, for example, for staging, we deploy different branches. It modifies a branch. Then we actually, based on that new revision, we run some separate tasks that we need to run, for example, migration. So we run the migration, we verify that it's successful, and if it's successful, all the sub-tasks are successful, only then we launch this Amazon blue-green deployment where we actually update the service with new task definition. So, and then Amazon handles pretty much blue-green deployments themselves. So, but yeah, for that we wrote a custom script because we needed to support some custom tasks. We couldn't just like click and update like it's like Amazon initially designed it, because we run a Rails app, and in Rails you have to run some multiple different things. Alright, so where were we? So as you can see, everything was created, and I'm gonna show you fast how the create stack, or let's say let's try to update the stack and see how it looks like. So you can also create a change set for a current stack, which means like right away you can use current template, or current template means it will not use your current template that you uploaded to Amazon S3, for example, but the current template that was designed. So if you uploaded a new template in Amazon S3, you will have to specify the template URL once again. That is also one annoying thing I found out. Or when you choose this upload template to Amazon S3 and you like choose upload, it actually creates a unique name for a file, and it uploads it like once again. So if you, I don't know, if you have done it 100 times, you will have a random S3 bucket that Amazon created with 100 random files inside, which is also not so cool. So here you can see that you, for example, if you define a random task name, and let's say you changed one of the parameters. Then you will you created a change set, and it actually will show you what will be changed in Amazon. As you can see, it says that Amazon EC2 subnet will be replaced, and subnet root table association will be replaced, meaning that the old one will be dropped and it will create a new one. So actually, with a change set, you can validate some minimal things that will be done before you do your update, which is also like a cool thing. So yeah. So somebody was asking about the export. You can see the exports here. These are the global exports that are here as an export name and export value, and you can reference that given export in another templates, which is like you usually export some global values that you want to use. For example, I want to export one single VPC values because I'm gonna launch 14 different apps and they're gonna same VPC, so I don't want to link them. I'm gonna just reference them every time I launch them. What else? Amazon recently created a new thing, is stack sets, but it's like a month old or something like that, and it's for more complicated setups when you want to launch your one single stack, let's say in 5 different regions. You create a stack set. In stack set, you define that launch me one single CloudFormation file, and I know 5 different regions. Then you, with a click of a button, you have exactly same environment created in 5 different regions. Just like that. It's also pretty scalable, I would say. One thing.
Regions except China.
Yeah.
Because, yeah, in case in China, you have to basically clone everything to AWS China.
All right. So what just we solved with this example based on previously, let's say, manually things that we created. Your instance will die. Well, you don't care. Let's say you defined now, you properly defined the auto scaling and everything, and what was installed inside your instance, you'd also define the user data inside this CloudFormation. So if your instance will die, it will just relaunch a new one. This is how we actually run, we will try to run the new production. Or, for example, Netflix runs it like that. Netflix created a tool called Chaos Monkey, which actually goes through Amazon and randomly deletes your resources. Like in production. Pretty scary, right? It will choose a random resource and delete it. And then you you remember everything you did. It's in GitHub now. It's source coded. You can't scale. Well, you just did. Now when you want to scale, you will write some cloud watch alarms and rules and modify your auto scaling. You will also do that in a file, and it's easily scalable. And you can copy exactly the same stack in a new Amazon account or like region. It's like easy. Now you are not scared to modify anything, because first of all you will actually see what will be changed in a stack set, plus somebody else can do the code review and you can both validate that actually we are going to update this thing right now, and you can test it in staging. It's not going to be so scary.
One question. Who does code review for your configuration files?
Nobody. Right now I just update the production. It's all fine. Now I actually usually update staging, and then once in a while I put the updates in production. So, but my staging is exactly the same as production. It's created with the same file, so I'm not even scared. If it runs in staging, it's 100% it works in production. There are no changes.
Question.
Yep.
You said you created staging and production from files.
Yeah.
So in here you use some graphical user interface to change some parameters and stuff.
Yeah.
So how do you download the changes to the files that you started?
The parameters are not defined in a file. The parameters are made on purpose that basically, for example, a parameter will be a branch name that you want to launch your application with. So the parameters are like, you can see them in UI, but if you modify, like if you want to modify some resource, you don't do it in Amazon or in this UI. You modify it first in the file, like you push it to GitHub, and you have some automated Jenkins tool that actually, based on your push, and launches the update or something like that. So nobody should actually modify the Amazon by hand anymore. It's like, for example, in our company, it's not allowed anymore. You shouldn't modify anything by hand. If you want to modify something, you do it in a file. and you push it to a Git, and then we do a code review, and then we actually update the stuff.
But for example, if you described a CloudFormation stack, created it via command line, stored the files in version control, and then you did something to CloudFormation as you just did in UI, can you get the changes back like with the same files?
No, but you will not modify the files. That's impossible. You can only modify in UI. You can only modify the parameters.
Okay.
But parameters are like kind of values. You don't care if they're like different or not. For example, the branch name. You don't care. It's like a parameter. You just reference it somewhere. So the actual resources will be the same. Resources will be untouched. Just the parameters are used inside the resources. For example, I don't know, security group ingress or something like that.
Well, in your example, you changed the subnet address, right?
Yeah.
Yeah. So is it also a parameter?
Yeah, but it's not gonna affect anything. It's just gonna run in the different subnet.
Okay.
So in production, we have totally different subnet start.
That you got to communicate somehow, like what is the subnet address?
Actually, you still don't care. You launch it and everything in there. When your developer wants to know what are the IPs, I have some commands or wrappers where you just like, get a list of current running servers and their IPs. Because as I said, the first one, your instance will die, you don't care. Whenever we have a problem and we don't have time to debug what's wrong with the instance, it's not responding or something, you just delete the instance. And it will launch a new one in a couple of like minutes or something. And your application is not down because you have multiple instances running at the same time. So, yeah. As I said, now if you don't modify anything in Amazon and nobody has like permissions because you defined permissions here to do that, there will be no missing things from documentation. And you can actually once in a while you should actually test this your Amazon as well. That you can delete all the stacks, and you can, let's say you deleted all stacks in staging. Now you go to Amazon, you can see that if there was some resource undeleted, it's because some mother F created the resource manually, then you kick his ass and you tell him not to do it anymore. So, well, debugging in Linux instance sometimes you still have to do it, but you have to do it less often now because, as I said, if you made it work once, it's probably working, and if you haven't updated your user data or what's inside your newly launched Linux instance, well, you don't care. You just kill the instance. It's going to launch a new one with the same stuff. You don't have to test it. It was working, and then it's working. It's just sometimes an instances can just get not responding anymore because there is some, I don't know, global networking problem or whatever. You can't reproduce exactly the same environment. Well, now we can. You have the same file with just reused parameters. They're called differently. You can just launch a new environment, and that's it in a couple of minutes.
Question about those environments.
Yeah.
For example, let's say you have a reason to have static IPs for production.
Mm-hmm.
Because they're written somewhere else, somebody is using those static IPs. So how would you give them out? How would you define them? If you define them in parameters.
No, yes, we have actually as well static IPs, and the reason is, yes, as I said, there are partners that might use your service, or you might use their service, and they want a static IP, and like you don't want to every time you launch a new stack, because you don't want to contact them and tell me, hey, we have a new IP, please update it. So what we do, for example, is it's the only Amazon resource that is created manually, and it's in the guides. So before you create a stack, you should have 2 like elastic IPs created. Or you have them hard-coded, and you cannot modify, you cannot delete them, or like you can't even create a stack without providing them there as parameters. If you don't have these 2 elastic IPs created beforehand, you can't create a stack. So now we created 2 these elastic IPs, and when you create a stack, we just pass them as parameters, and that's it. So there are these cases that elastic IP, you should have it, like for example, always. Or let's say if you're an enterprise client, probably you can speak with Amazon, and Amazon will create 2 elastic IPs for you that whenever you delete them, they are still there. When you create a new stack, they are still there. So, but yeah, this is a workaround we use. We just create them manually first, and that's it.
And normally, if you have an elastic IP resources, I cannot think of a situation where you could possibly want to delete them because they basically do nothing besides being an IP address, you know.
Well, Amazon can restore it, so that's cool. So plus also you can always contact your partner and tell them you updated your IP. Well, not a big problem, right?
If you have a couple of thousand.
Yeah. Well, then you definitely want to use CloudFormation in order to define the policies what developers have access to where, and you make sure that you don't give the right to modify the Elastic IP, because you know somebody gets drunk, he goes to UI, he clicks the wrong button, and the stuff is down. I have some personal problems with Amazon CloudFormation besides these problems and cons I brought out when I was comparing it with Terraform. The first one is a little bit buggy Amazon command line tool commands. First of all, for a CloudFormation, it's not so user-friendly because it requires you to print out every parameter. And sometimes Amazon CLI, I found out when I was trying to, describe some parameters from, by filtering some things out, it was sometimes giving me strange errors or crashing, and then I figured out that there are bug issues open or something like that. Quite complicated to filter parameters. It's also in Amazon CLI tool. So if you ever try to filter out some parameters and to write some custom filters, they use some templating engine. I don't remember the name or how it's used, but it's becomes quite complicated. And with CF, it's extremely long commands, and well, no user-friendly input, because perfectly in ideal world like a Terraform, I would like a CLI tool where I pass in write extremely small string, create me a new stack. I pass in a file, and for the resources or parameters that I need to put, it prints me out every parameter saying please input, please input, please input. Like they do it in UI. I don't know why it's not done in CLI, that I have to provide every parameter beforehand. Well, my solution to that, I started writing a little command line wrapper for that written in Go. But right now I wrote it a week ago, and it has only one command, list parameters from the CloudFormation, and it's extremely short already. So right now I can just, when I want to list all the parameters in existing CloudFormation file, I can just write extremely short command, and that's it. And I will be.
Welcome to contribute.
Yeah. If you're also pissed off by the Amazon CLI and you don't like clicking in UI, then go ahead. I even created a project and there are ideas. So, any questions?
Have you tried anything else other than Amazon?
No, because well, when we were startup, we just started with Amazon, and then we grew bigger. Then we ended up in Amazon, and we didn't have any reason to move anywhere else besides Amazon, because the price range would be exactly the same, a little bit different, but it's so small differences that let's say my opinion is that when somebody says that Amazon is too expensive, then I say that your resources are shit, go and rebuild your structure, because it's actually not that expensive. For example, our builds are quite small considering we are a bank.
Other than that, maybe anybody knows what else cloud providers also offer infrastructure as a good first place?
Yeah.
Besides OpenStack.
Google offers, but I don't remember the name.
Kubernetes?
No, Kubernetes is for launching the Docker. It can be used outside the Google, it can be used in Amazon. But Google, as in Google Cloud, there is also a tool, which is a similar tool. It's also YAML, I believe, or JSON. And in Microsoft Azure, I'm not sure, but when I checked, I think there was a tool that you had to download, some .NET or something like that, and use some Windows tool where you actually do this tool. So yeah. Yep.
Have you tried configuring CloudFront with CloudFormation?
Yeah, we have it configured.
Any caveats?
No, but we have extremely simple CloudFront. We have, let's say, a CloudFront to run one static to serve one static web application, and that's it. Or actually not even that, some assets out of that. So some static pictures, images, and so on. So
Can you also 53 through CloudFormation?
Yeah, I actually do that, but not in our current company. I have my own consulting company where I provide Amazon consultant service, and for one customer we actually did that. And then you can actually, like, if you don't want to relaunch your Route 53 in some other like environments, you create one single stack and we have everything defined there. So the Route 53, we have everything also defined in a stack, and everything's like written in a file. So when you create a new Amazon account, you have your domain registered, or you want to register it first, you can just click it. The same with the Amazon SSL certificates, but the only caveat with Amazon's SSL certificates is that when you register it, it sends out an email to this domain registrant, and you have to like confirm the email. So when you create a stack, it actually, you can see the stack will stay in update in progress unless somebody clicks on like update link.
From the email?
Yeah, but you can also set some timeouts on CloudFormation. That's also, actually I forgot about like saying about a little bit of the problems I found with Amazon CloudFormation. There are chances you can get your Amazon CloudFormation update in progress get stuck. For example, when you are updating Amazon ECS service, and as you said, you can make some, I don't know, you fucked something up and your ECS service is not getting launched. Well, it's not healthy, it keeps crashing. And Amazon CloudFormation will just wait until it's like considered healthy. So one workaround is either do a rollback, which might not always help, because some applications, for example, as you say, it used some revision, and this old revision is also now broken because of some environment variable. Then you can just update the Amazon ECS service to desired instance counts 0 and just wait until it's finished. Or there are more complicated problems. In Amazon CloudFormation, you can create custom resources, which are Lambda functions, which basically what will happen that during the CloudFormation creation, some call is made to your Lambda function, and in Lambda function you have to answer to Amazon the CloudFormation saying that it succeeded. And I just did it today. I made some custom function. I was testing something and it got stuck in rolling back, and now it's literally stuck. So I had to, in this kind of cases, you have to contact Amazon and just wait, because they don't have any workaround. If you literally created some custom resource like a Node.js function and you fucked it up and it's literally stuck, still everything's still up and running except that resource, but that resource is not relevant, so well, you just have to wait.
So it's useful to have business support on Amazon if you run CloudFormation.
Yeah, well, that's why you should also test your CloudFormation in non-production environments, of course, when you're writing something new, of course. So yeah.
Well, I guess time for question is up. If there's more,
You can contact me here.
Check with Andres directly. Big thanks for visiting us today. So thank you guys.